Hello. I've been thinking of a simple way of showing why good quality data affects model results. Majorly trying to delve a little bit deeper into the data-centric approach in data science. And the aim is to explain why if you give a model a low quality data, you would have low quality results. And if you give a model high quality data, you have a high quality result. So in this case, I'm just going to be explaining this using a simple linear regression uh, that focuses on just giving the outputs of two times the value you give to it. So that's just two times any value you give. So in this case, I created my X and Y values. My X is value from 1 to 7, and my Y is two times each of those values, which is correct at this point. Yeah, we have our weight just initialized to 0 at this point, and the weight is what we want to optimize, right? We'll continue to update the weight until it gets to a point where it's being able to like get the actual value that is meant to use to multiply with X. We have our loss arithmetic squared, and I just have a test value that's 5.0. So at this point, because my weight is 0, if I pass my test value 5.0 to this particular forward, it's going to be 0 times anything, which is 0. Highly expected. But we expect it to be correct at the end of our iteration once we are done training. So now I have my learning rate as 0.1 and my airport as 100, right? And I'll just pass it forward to the model, calculate the loss, do backward propagation, and also update the weights. All right. So after each 10 iteration, each 10 airport down to see what the model weight is. So you can see we're having very good results. This is simple linear equation. But let's say in our data, we changed this value to like maybe 1. Now we've corrupted the data. The data is not correct, right? For just one value. And you'd see that irrespective of the number of iteration it does, the model output is now slightly away from the model results, right? Majorly due to the wrong data that we passed to it, right? If we remove another value and we corrupt it further, we'll see that the model result keeps decreasing, right? It keeps decreasing. So let me change it back to the correct value. Two, 2 times 2 is 4, and 1 times 2 is 2. Right. Here now, let's focus on, if we run this, we'll see we have 10.0. Right. So let's focus on hyperparameter tuning. Now, in hyperparameter tuning, you'll be like, okay, let me reduce my airports to like just 5. Right. Let me reduce this to like 2. Let me do 15. I make this 5. Airports to 15.5. But yes, we still get the correct results. So if you focus on, if you are given a data and in any data science project, if you are given a data and you've not worked on like polishing your data and ensuring that your data is of high quality by doing exploratory data analysis or doing feature engineering or feature selection to improve your data, then just doing hyperparameter tuning of doing 0.2, 0.1 for the learning rate for this would have slight effects on the model result compared to ensuring that the data is of high quality. Yeah, I hope I've been able to like explain this simply. Like it's just something I'm really excited that I was able to like get by just looking at it in a small and a simple environment. Thank you very much.